Okay, we're continuing with example problems on infinite series. We're analyzing infinite series to see if they're convergent or divergent. And if they're convergent, we want to state what the series is equal to, the infinite sum is equal to. So here we're going to be given series, and for these problems, the sequence formula is going to include a variable. It's going to include an x. And what we want to do is we want to state for what values of x is the series convergent. And then for those values of x, what is the sum? What's the infinite sum? All right, so it looks like this. We could write this as a geometric series. So, and we know we know how to work with how to evaluate geometric series. Okay, so based on this property of exponents, a b to the n power is equal to a to the n, b to the n, we can say this. Okay, so there you go. That's a geometric series, clearly, with a common ratio of minus 5x. All right, now what is the first term of this geometric series? Well, when n is equal to 1, we see it's minus 5x. All right, and then the common ratio is, we come over here, the common ratio is minus 5x. All right, so we want to solve for what values of x is this series convergent. So what makes a geometric series convergent? That's when the absolute value of the common ratio is less than 1. Then the geometric series is convergent. So we want to solve for absolute value of minus 5x is less than 1. Let's solve for x. This is an absolute value inequality. We learn how to solve these in algebra. Okay? So going back to the college algebra textbook, on the absolute value inequality section, it says, so we've got a number k, a real number that's greater than 0, and that's 1 in this case. If you have the absolute value of some expression of x is less than k, that's equivalent to this. U is less than k, u is greater than minus k. So we have, there's the u. Okay, now we want to divide this entire inequality by minus 5. And then when we divide or multiply both sides or all sides of an inequality by a negative number, we need to flip the inequality symbols. Okay, so we can rewrite this as and there we go. This series is convergent for these values of x. Now, I'm not sure what the actual infinite sum is given by this formula, but the r can be, anything, minus 1/8, minus 1/16, 1/8. It can be anything in between these, in this range, so I'm not sure what the question is asking. I guess just, oh, no, I see what it's asking. So we use this here. So, okay, the sum is equal to minus, a1 is minus 5x over 1 minus 5x. So 1 plus 5x. Okay, but with this condition here. Okay. Okay, let's see if we can put this into the form of a geometric series. That's all we've learned is as far as convergence of series is the geometric series, but there's also the telescoping series, but I don't know how that would come into play with the questions, with these questions, but I'm going to assume for each one of these questions, we can put it into the form of a geometric series or something of that nature, but we'll see. Maybe they'll throw us a curveball. So, okay. Here we can write this this sequence formula as this, and I'm assuming that's what we need to do. Yeah, definitely. Okay. So, and we're starting at 0, which doesn't matter. Okay, so we've got x. All right, and so for this to converge, we need, okay, well, the A1 is what? X. There's A1. Oh, no. That's not right. The first term is 0, is the 0th term when n is equal to 0. And so, okay, A0 is 1, so that's the first term. It's kind of confusing. This formula here for the infinite sum, I guess that's why they don't put a subscript. This is the first term. Doesn't mean n is equal to 1. It's the first term, whatever the first term of the series is. And so in this case, the first term is when n is equal to 0, and this is 1. Whatever it doesn't matter what's in here. It's to the 0th power. All right. Now, for the series to converge, what has to happen? The absolute value of x minus 2 needs to be less than 3. Not less than or equal to 3, less than 3. The absolute value, right? Because you could have this could be -1. X minus 2 could be -1. That's fine. Or it could be 1. All right, so absolute value equation. We've got the expression is less than the number, so it's the same as before. That's going to be x minus 2 is less than 3, the compound inequality. Okay, now we want to add 2 to all sides of this. So minus 3 plus 2, and then 3 plus 2. There we go. So that's the range of x's. Not equal to 5, not equal to -1, but just between that. So, all right, so again, S is, okay. So A is 1, and R, oh yeah, we didn't put R. What is R? R is x minus 2 divided by 3. Okay, so 1 minus, okay, so now we want to multiply this by 1 in the form of 3 over 3. So 3 minus, so 3 minus x five. Okay. So yeah, there we go. You can input any one of any value within this range, any x, into this formula, and you'll get the infinite sum of this series, which is pretty cool if you think about it. An infinite sum. All right, this looks like a standard geometric series where r is equal to 2 divided by x. The first term is equal to 1. So the absolute value of 2 over x needs to be less than 1. All right, so okay, but if we look at this, what we see is that this is the absolute value of x needs to be what? It needs to be greater than 2, right? If the absolute value of x is greater than 2, then you're always going to have something this is going to be a decimal, not 1, some kind of decimal, either a positive or a negative decimal. Okay, so in this case, we've got an OR inequality. So we've got the absolute value of u is greater than k, so we've got that x is less than -2 or x is greater than 2. Okay, so there's the interval where the series converges. And so let's see, we might have to have two separate sums here. So a is always 1. And, well, no, okay, we'll just do and then multiply this by, so there we go. If x is less than -2 or greater than 2, then you can use this formula, plug it into this formula, and get this infinite sum. Okay, so we can write this as, from properties of exponents, we know that if we have a to the b to the c power, that's equal to a, right? So we can say e, and that's a geometric series. The first term is n is equal to 0, so first term is 1. And we want to, the common ratio is e to the x, and so the absolute value of e to the x needs to be less than 1. But e to the x is never 0 for all, like the domain of e to the x is, you can input any number, but if you think about e to the x, that's never 0. So we can just take off the absolute value. Okay, now let's take the natural log of both sides. We get x is less than the natural log of 1, x is less than 0. And this makes sense. E to the 0, it's 1. Anything greater than 0, it's greater than 1. But when x is less than 0, e to the x, it's never negative, but it becomes less than 1. So x is less than 0. And then we've got the sum is 1 over 1 minus r. And there we go. Okay, this is a geometric series. If x plus 2, if the absolute value of x plus 2 is less than 1, then we have a geometric sequence that converges. This is just a common ratio here. We're multiplying each term, we're just multiplying by this x plus 2 every time. We start with when n is equal to 1, we start with x plus 2. Then when n is equal to 2, we just multiply this times x plus 2. Then when n is equal to 3, we multiply the previous term by x plus 2. Right? The common ratio is x plus 2. So, okay, absolute value equation, we've got subtract 2 from both sides. Okay, so the sum is, so 1 minus r, like that. So we've got 1 minus x you've got minus x minus 1. So we can do this. There's the sum. Okay, so based on this property of exponentials, we can write this as, okay, minus 4 times x minus 5 is going to be 20 minus 4x. There we go. That is a geometric series with the first term is equal to 1 when n is equal to 0, and r is equal to 20 minus 4x. So we need for this to be convergent, we need the absolute value of 20 minus 4x to be less than 1. So subtract 20 from both sides, or all sides. Okay, divide all sides by minus 4, so 21 over 4, flip this, so we've got okay, and then the s 1 minus 20 minus 4x, 1 minus 20 is minus 19, then plus 4x. There we go. Okay, so it looks like all of these are just geometric series related, which makes sense because I don't know how we would do this. We don't have enough. We haven't learned enough yet to go beyond a geometric series for a question like this, I feel like. All right, so we've got right. So the first term is 1, n is equal to 0. The common ratio is, okay, now we need the absolute value of sine of x to be less than 3. So this means that sine of x okay, so take the inverse sine of this entire inequality, and we've got actually, okay, hold on. I should have noticed this. Looking at this, do we need to solve this? No. The answer to this is any x. I don't know how you write that. No matter what x you put in, it's always going to be the absolute value of that's going to be less than 3 every time because the sign is the range is minus 1 to 1. So this is it. Like if we put in, it would probably give us an error if we tried to evaluate the inverse sine of, yeah, there's no inverse sine of negative of 3 because you can't get, you're only going to get between 1 and minus 1. All right, so S is 1 minus, all right, so we multiply this by 3, okay. And there we go.